I am Dean Bushmiller with Expanding Security, and this is Network Communications Principles and Practices. Use or consumption of this material by AI is expressly forbidden. Let's get started. Network Communications Principles and Practices. I've talked about the layers in other recordings, but I wanted to give you a setup for network communications. This is not the security, this is the communications itself and how do we get this stuff set up. For me, when I look at this, I start with the requirements and the topology planning. That's really where it starts from. I would like to walk in and not have anything in place whatsoever, walk in the first day and they say, hey, we need a network. That doesn't happen, okay? We get in there and, 16 things have happened before that, and a cousin came in and wired up this thing, and he did the specification B, and I did the specification A, and that's the way it is. And I really love on YouTube, there's a whole subclass of rewiring networks where people come in and they show the whole process from ripping out all the garbage. But we want to map the logical flow to start off with by figuring out what the zones are in this organization. And so what you'll do is you'll separate your network into functional enclaves. So you start off with just generally, it's usually clients and servers is where it starts, but then we got to break it down further when we get into this with users, servers, and if you have any IoT guest or management. For me, I also want a separate place inside of here that's called printers. I really want to segment them off because printers are getting really smart these days. Then I'll figure out what topology to use. Is this going to be hub and spoke? What is this going to look like? When we have a wireless network, we have different classes of service there. The best way to do this is to follow how Cisco has laid this out over the last, 30 years? And that's the three-tiered architecture. It starts with the core, which is our high-speed switching, which is also called the backbone. This is where most of your egress to the internets or internets that you have are set up. Next is the distribution layer, and that's the policy-based connectivity. That's the routing between VLANs if you have them. I hope you're deploying VLANs in your environment. And lastly is the access layer. That's where the devices are plugged in. This wireless access point that sits up in the ceiling, that's the access layer, and it has several VLANs hanging off of it going in and setting up all of our different clients that we may have. Next, we set up an IP scheme and subnetting. Here's the first rule I want to get into. How many people do you have? Do you have 3 or less? Okay. After 3 people, you should not be using the ISP's router. They'll give you a DHCP address that's handed off from them with a DNS server and a whole bunch of other stuff. As soon as you see 192.168.1 and you've got 3 or more, you've got a 4th person on your network, this is not a solution. You also don't want to be using something like a PIPA. You'll know these two because of the starting address for assignments for each one of your devices out there. That's what you want to look at there. Okay, so how do you do this? Well, what we should be using is RFC 1918, non-routable addresses, and using them consistently for our IP address ranges. I like to use the internal 10 network because it's so flexible, and that gives me millions of addresses. What it really gives me is it gives me these other octets to play with. I don't know if I would use the 172.16 through 32, that /16 network. I don't know if I would use that, but I have seen that used in military operations and it worked out pretty well. Okay. So we're all going to use the 10 network. That means we've got 10, an octet that we can play with, another octet that we can play with, and then we've got host on the end. The second octet, the 10x, is used to identify the site, the physical location in a lot of cases. It might even be, if you're a smaller organization, it might be setting you up on a per floor basis. That's your first level. Your second level is to identify the VLAN, and you can have that same VLAN in that third octet, the Y octet. You can still have that same VLAN on this floor and then have that VLAN on another floor. So then the second octet changes and the third octet is the same between them. So you can identify those patterns there. But you've got to set this up so that you can plan for growth. I don't know how many devices are in your network right now. Just in my home network that I have at home, between the Between the vacuums on each robot vacuums on each one of the floors and all of the other different internet connected devices, I probably have like 40 or 50 different IP addresses that are in use in my home network. Imagine what that looks like in an office. So you got to plan for that growth there. Remember, that's going to spread over time. So one person could drag, 25 IP addresses that would be reasonable and necessary for them. I always use the CIDR notation. You didn't hear me say .255, .255, .255. Don't do that. Use the slashing, /8, /16, /24. This also, if you're setting up like this conforms with a lot of the Cisco nomenclature that's out there, so that makes it a little bit easier for us to deal with. Okay, we've got our IP address scheme down. That's layer 3. Let's back down into layer 2. What we want to do at this point is limit broadcast domains. That's the ultimate goal there. Broadcast domains, we don't use hubs anymore. Well, wait a minute, we do, because the wireless access point, this is a hub. Let's call it what it is, because it's a contention-based network. We use CSMA on this to create slotting mechanisms, but we may want to go ahead and limit those broadcast domains by putting extra, and these things might have multiple antennas inside of them. You can't see them because the antennas are all wrapped up inside. But we want to limit those broadcast domains that we're dealing with. What we can do across switching is we can implement VLANs, which is also called 802.1q. We have to figure out how to assign those VLANs. That's usually done through network access control methodologies that are out there, but we can do that through the authentication process if we want to. If I step onto the wireless network and I say, "Hi, I'm a guest," and it says, "I'm going to put you on that VLAN right over there," or I don't say anything and I've got my laptop from work connected up, it'll go, "Oh, I recognize that asset. I'm going to allow that asset onto this network. It's not going to be with the guest. I'm going to put it over here." You can divide this up any way you want to. I say at least servers, users, cameras, IoT. I would group printers. And then for the users, you might, delegate that into groups. You might have the accounting department here, the research and development department over here in this particular VLAN. Because you have theoretically at a VLAN addressing standpoint, you've got 65,000 different VLANs. But if you're doing a third octet, you have 254 VLANs per location. I think that that's enough for most organizations that are out there. Next on this, we start getting into a little bit of security. Remember, this is not about security. We want to say disable the unused Ethernet ports. So that jack on the wall that you can plug into, like even if you were to see like this hanging above my desk, it's like on a shelf above my desk, and you see that port and you go to plug in there, it won't activate because you've administratively turned this thing off. You've physically shut down those extra ports here. Normally, you don't see this device sitting above somebody's head. Maybe you do in small organizations. Normally, what you see is you see a jack on the wall, and that leads back through into a wiring closet that's sealed off, and then that's connected up here so that could you plug in there. I have done penetration tests where I walked into an office and I just leaned down underneath. I saw, oh, I have a computer here and I can plug in another computer right there. And sure enough, away I went. So shut those ports down. In port security, not the physical port, but the logical port on the device, you probably want to deploy at least network access control, which is in another video that I've talked about previously, or use zero trust, which is in another video that I've talked about previously. That's layer 2, well, almost. Let's talk wireless. Be ready for the next version now. I currently do the current version of wireless, which is the AC11. I using version 7, okay, is what we're doing right now. Probably by the time you watch this video, it'll be the next version. But you've got to be ready for those versions because the devices are continually getting better and better and better, and they're demanding more and more bandwidth. So you want to work with each one of those tools that's out there. Be ready for the next version of wireless today. Today, what you want to do in networking is you want to have your wireless and you have your wireless LAN controller. This device right here that you see is an old Cisco wireless LAN controller, and 2 of the ports on this are power over Ethernet. That means that I can run an Ethernet string between the 2 of these things, put this up in the ceiling, and I don't have to worry about that there's a power connector on here, but I don't have to plug in the power. I can plug into the yellow port right there, and I can power this device. Remember that power needs to be matched up on both sides. Okay, a little bit more security in here because it's kind of a security course, but it's not, is security perimeter and DMZ. You want a stateful inspection firewall. That will allow you to segment your networks and know who's coming and going, who's initiating the connections. First thing that you build is a shared services network. That network is going to be for any services that are public facing, like a web server, or maybe it's just in your really small office, maybe it's just a connection to the internet. That might be all it is, okay? The stance that you want is default deny. That means don't let anything through. Only open specific necessary ports, and usually in small offices, the answer to this is none. Maybe the VPN to get in, maybe, but probably none. So that's kind of the default deny of all courses there. And especially with the proliferation of web services out there for our web servers, our mail, and all those things are being pushed into the cloud, none is a good option. Essential infrastructure services that we do need to have internally that may need to signal to the outside world, but only to specific servers. First and foremost, DNS. I've said this in a lot of other presentations. If you control DNS resolution and you have reputation-based filtering on DNS, you're going to clear away from a security standpoint 90% of the clutter that's out there. Because if I walk into the organization and this device is useful and it's been compromised by an adversary, and I come in and I connect up to this wireless connector here, the first thing that my compromised device is going to do is going to signal. It's not going to signal by IP address in most cases. If it would, there would be a definition pretty quickly out there that would go ahead and eliminate it. But it's going to signal by DNS. It's going to go to evil server that's owned by somebody else, .AC, whatever that thing is. When it goes to signal and it goes to resolve that, if you control the resolution for that command and control, for that channel of DNS, what you're going to say at, not the wireless access point, but at the DNS server internally for the organization with reputation filtering on it, you're going to say, sorry, I'm not going to let you connect there. And so therefore, there is no command and control. Is the device compromised? Yes. Can the device signal and then start attacking the rest of the network? Not really. I mean, normally they're not autonomous in their nature to go ahead and do all the signaling here, collect this up and go somewhere else. That'll happen to us in the future, but it's not happening right now. I think I've given it away at that point. The other thing that you want to control is DHCP. You don't want to do default ranges for 192.168.1. It's too easy for an attacker to then do some scanning there. If you switch that off, even if you're a 5-person network, if you switch that off to a 10 network and you start assigning IP addresses there, you'll gain an internal understanding. Your adversaries won't know it. And what's really cool is the first thing that an adversary is going to do when they get onto your network is they're going to stand up a 192 network to try and blend in. And it won't. It'll stick out like a sore thumb because we're going to get to monitoring in a second. NTP. If you have a local authentication server or a remote authentication server, you're going to need NTP. But what you really need NTP for is things like forensics after the fact. All of your logs need to be correctly timed so you can say, when they came in, they came here, then they went through this device, and then they went through that device, and then they went through that device. And how you know that is each one of these things has its own network, has its own time synchronization of all the other devices on the network. Incidentally, for NTP, DHCP, and DNS, I would even, and this is not a honeypot, I would even set up false services that are inappropriate that our adversaries may go after that look like the standard ports and standard protocols and route them to a dead VLAN of some sort. Management and monitoring. This is our last big section here. For management and monitoring, what I would say is out-of-band management. That means manage your switches and routers on a dedicated, isolated network that can only be reached by administrators, not special people, but the people that run the network. That's where you want to drive all of those things. You're also going to turn on SNMP for all of your devices. That includes all of those wireless LAN controllers that you have out there, or if you have servers locally, you're going to turn on syslog, and that's all going to be pumped into some centralized syslog server or SIEM. And by the way, for this, what I would truly do is make it that wherever it sends those messages to, that's not an IP address that can be reached by anybody on the outside world. Lastly, network communications are going to change on a daily basis, and you need to be ready for that. It's just as simple as that. So I hope you'll join me for the entire presentation.